Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of TALLENTEX, we're going to be looking at some sample questions of Alan's TALLENTEX examination. Now here we're going to be looking at a multitude of subjects, and we'll be looking at questions in detail and how to solve them effectively. So we're going to be looking at grade 10's sample paper. Now let's start off with our first question. This one is from physics. If other factors remain constant, which of the following combinations of number of turns per 20 centimeter and electric current respectively in a solenoid produce the weakest electromagnet? Is it 500 turns and 3 amperes, 700 turns and 2 amperes, 200 turns and 5 amperes, 300 turns and 4 amperes? So here the idea of the question is to give you the length of the solenoid, and we need to find out which combination of turns and current produce the weakest electromagnet. Alright, so for this we need to find out the strength of the magnetic field. So that is represented as B, and it's equal to mu naught times lowercase n times I, where mu naught is the permeability of free space because it's not. Then we've got I, which represents current, and n stands for number of turns per meter. Now here this particular value n can be represented as capital N over L, where uppercase N refers to the number of turns and uppercase L refers to the length, which in this case is 20 centimeters, which can be written as 0.2 meters. So the formula that we're going to be using would be B is equal to mu naught times N I over length, which is 0.2. So B is equal to mu naught times Ni over 0.2. The N we're using is uppercase because we know the number of turns, the absolute number of turns. So now from this particular question, we need to check out all 4 options and find out which has produced the least magnetic field strength. So for option A, we've got N equals 500 and I equals 3. So therefore the value of B turns out to be mu naught times 500 into 3 over 0.2. Now 0.2 is basically 2 by 10. 10 goes to the numerator. 500 becomes 5,000. 5,000 over 2 is 2,500. And when you multiply that by 3, you get 7,500 mu naught. So this is the value of the magnetic field strength according to option 1. So in option 1, the value of B is 7,500 times mu naught. Is it going to be the lowest? Let's check out the rest. Now for option number 2, the value of N is 700 turns, and the value of I is 2 amperes. So therefore the value of the magnetic field strength would be mu naught times 700 times 2 over 0.2. So again, 700 times 10 gives you 7,000. 7,000 by 2 gives you 3,500. times 2 into mu naught, which gives you 7,000 mu naught as the value of the magnetic field strength. So it looks like option 2 is already has lesser B value than option 1. But is it going to be the least? Let's look at the others. Option 3. This time we have the number of turns is 200 and the current value, the value of the current would be 5 amps. So here magnetic field strength is equal to mu naught times 200 times 5 over 0.2. So 200 divided by 0.2 gives you 1000, which means that 1000 times 5 would be the value inside the bracket. So we get 1000 times 5 into mu naught, which gives you 5000 mu naught. Finally, we have option 4. Here we have the value of N as 300 turns, and the current is equal to 4 amps. So over here, option B, the value of B, magnetic field strength, is equal to mu naught times 300 into 4 over 0.2. So again, using the calculations, 300 over 2 gives you 150. 150 times 10 is 1500 times 4. We multiply that with mu naught to get our answer as 6000 mu naught. So option 1 is 7,500. Option 2 is 7,000. Option 3 is 5,000. Option 4 is 6,000. So as you can see, 5,000 is the least value of the magnetic field strength from the 4 options. So therefore, according to our calculations, we can successfully conclude that option 3 is the right answer. The idea is to use B equals mu naught Ni over length. Here length is given, so we plug that value in, and the values of N and I are given in the question. So by substituting them and finding out the answer in terms of the permeability constant, that's mu naught, we will get option 3 as the right answer. Now let's look at a question of chemistry. Which of these is a solution? So a solution is where the solute mixes with a solvent. So a solution is what we call as a homogeneous mixture. So we've got 4 options. We've got 14 karat gold, salted water, carbonated water, all of these. Now we know that salted water is actually a solution. Salt is dissolved in water. So therefore, option 2 is definitely correct. But if we were to put that as the right answer, then we'll have to consider 14 karat gold and carbonated water as incorrect. Or the option that all of these being correct is also considered incorrect. Now if you look at carbonated water, it's basically CO2 dissolved in H2O. Now this is done under high pressure, not exactly under atmospheric pressure, because at atmospheric pressure the gas would just bubble out. So this is done at a bit of a higher pressure than atmospheric pressure, and it's basically containing gas, the carbon dioxide gas, which is mixed in the solvent that is water. So therefore, we can see that carbonated water is also a solution. We also know that salted water is also a solution, so since 2 and 3 are correct, the only option that makes sense is option 4, all of these. So if you're wondering if 14 karat gold is a solution, it's actually a homogeneous alloy. Now, alloys are usually considered to be heterogeneous, but 14 karat gold is one of the few examples of a homogeneous alloy. We have 14 parts of gold, which is mixed with 10 parts of an alloying metal such as silver or copper. So option for all of these turns out to be the right option. Now let's look at a question from biology. Which of the following strategies is not the correct approach to reduce global warming? So here we're looking for which is not the right approach. So we need to find out a wrong statement that will be considered as the right option for this particular question. We look at the four options, we see that option 1, cutting down use of fossil fuel, is incorrect. Now why is that? This is because this is a true statement, and if we cut down uses of fossil fuel, that means there's less CO2 equivalents emitted. So therefore, option 1 is a correct approach. However, that makes the option incorrect. What about option 2? Improving efficiency of energy usage. So that means you get more energy per unit fuel, which means technically you need less fuel to go the same distance or do the same work, which means less carbon dioxide emitted for the same amount of energy. So therefore, improving efficiency is also a correct approach, which makes the option incorrect. Reducing deforestation works because trees sequester carbon dioxide. So that means less CO2, so that means global warming's impacts are reduced. So that means the third statement is also true. It's a correct approach, which makes the option incorrect. The right answer is option 4, cutting trees and increasing growth of human population. If you cut trees, then there is less locking of CO2, so that means more CO2 that could have been locked away are actually present in the atmosphere. So therefore, that increases global warming, and if you have human population increase, then that means you need more energy. More energy equals more carbon dioxide equivalents. So therefore, option 4, cutting trees and increasing growth of human population, is the right option. It is the strategy which is not considered as a correct approach to reduce global warming. Now, let's look at a question on mathematics. If a plus b is given as 225 degrees, then find the value of 1 plus tan a and 1 plus tan b. So how do we solve this question? Well, let's look at the given equation. A plus b equals 225 degrees. Now, 225 is basically 180 plus 45. So therefore, when we convert it to radian, you get pi plus pi by 4 as the value of a plus b. So its total value comes out to be 5 pi by 4. So the angle in question is 5 pi by 4. So now we need to find out the tangent of this particular angle. So taking tan on both sides, we get tan a plus b is the same as tan of 5 pi by 4. So tan 5 pi by 4 is in the series containing pi by 4, so therefore the value of tan 5 pi by 4 would be equal to tan of pi by 4, which is equal to 1. So according to our steps so far, tan of a plus b is considered as 1. Now we will look at an identity here. Tan of a plus b is basically considered as tan a plus tan b over 1 minus tan a times tan b. So we're going to use this identity in this particular relation. So the left-hand side would be expanded to form tan a plus tan b over 1 minus tan a times tan b. The right-hand side is still 1. So since the right-hand side is 1, we can easily shift the denominator to the right-hand side. So what we're in effect getting is tan A plus tan B equals 1 minus tan A dot tan B. Because it's basically 1 multiplied by that particular term, the denominator. So therefore, it would still say the same. So now that we've got this equation, let's take tan A multiplied by tan B to the left-hand side. So we're going to get tan A plus tan B plus tan A dot tan B. Now the reason why is because we're taking a negative term to the left-hand side, so therefore it turns positive. The right-hand side remains 1. Now we're going to add 1 on both sides. So what we're going to get is 1 plus tan A plus tan B plus tan A multiplied by tan B. The right-hand side is still, the right-hand side would be 1 plus 1, which is equal to 2. Pretty obvious. Now here's the less obvious bit. The left-hand side can now be factorized, because here we can factorize it by 1 plus tan A. So when you factorize it by 1 plus tan A, we will get 1 times 1 plus tan A plus tan B times 1 plus tan A. The right-hand side still remains 2. All we have to do is group them effectively, so therefore 1 plus tan A multiplied by 1 plus tan B is equal to 2. And there you have it. We got our answer. Because if you look at the question, the value was to find the value to find was that of 1 plus tan A multiplied by 1 plus tan B. And by using the particular identities and the correct value of the tangent, we got 1 plus tan A times 1 plus tan B as equal to 2. So therefore, option 3, the value 2, is the right option. Now let's look at a question of mental ability to finish this off. So we need to find out which day can be the first day and last day of any century. Is it Monday, Tuesday, Friday, Wednesday? Well, at first glance, this looks complicated. While how on earth are you going to count every day of a century to find out which day can be the first day and the last day? Well, there's a simpler method to do it, but it does require some paperwork. Now, let's state out the obvious. The number of days in a normal year. The number of days in a normal year is 365 days. And 365 days can be calculated as 52 weeks, which is 52 multiplied by 7, plus 1. You do 52 times 7 here, you'll get 364. Alright, so 364 plus 1 gives you 365. That's for a normal year. Now, every 4 years, we get a leap year in general. So therefore, that gives you 366 days, which is 52 times 7 plus 2. So you have 1 extra day in every year and 2 extra days for a leap year. Now, when it comes to leap year, it's not that every 4th year is a leap year. There is another calculation that comes into mind in the Gregorian calendar. Now, years which are divisible by 100 are not leap years. However, there's an exception. The exception is when the years divisible by 100 are also divisible by 400. Now, these years are considered leap years. So in a particular century, we need to find out how many years are leap years and how many years are not. So it's a good idea to refresh on how to calculate the leap years. So it's technically every fourth year. However, if the year in question is divisible by 100, then it's not a leap year. The exception being if it's divisible by both 100 and 400, then it is considered a leap year again. Now, we will need to check out patterns across centuries. So when we consider the first century, the day starts, the century starts with a Monday. Now, in a century, technically people believe that it's 75 plus 25. However, that's not true because of the fact that since years divisible by 100 are not leap years. So because of that, the actual calculation for number of normal years and number of leap years is 76 plus 24. 76 is normal, 24 is leap. So here we're just calculating the number of days that are left over. So we've got 76 times 1 extra day plus 24 years times 2 extra days because they're leap years divisible over 7. We need to, categorize them into weeks in order to find out any extra days are left. 76 times 1 is 76. 24 times 2 is 48 over 7. 76 plus 48 would give you 124 over 7. And when you do 124 over 7, you would get 1. You would get a remainder of 5, 54. So 7 times 7 gives you 49. So a final remainder of 5. If you were to divide even further, it goes to decimals. We don't want that. We just need to write this particular improper fraction into a mixed fraction. So 124 over 7 is actually equal to 17 times 5 over 7. This 5 here represents the 5 remaining days. So 5 days in the first century are odd. So that means the century ends with the 5th day of the week, which is a Friday. We're using the Monday to Sunday system. So therefore the week starts on a Monday and it ends on a Sunday. So the 5th day of the week would be a Friday. So this is the calculation for our first century. Now for the second century, we would have an additional 5 days added to the list already. So therefore you have 10 remaining days. Now since the last century ended on a Friday, this one starts on a Saturday. Now 10, when you divide that by 7, you get 3 extras. So Monday, Tuesday, Wednesday. So this century, the second century, ends on a Wednesday. Now for the third century, the process is repeated again. So we have another 5 days added to it. 5 times 3. So we still have a total of 15 days, which aren't calculated into weeks. So this century, since the last one ended on a Wednesday, this one begins on a Thursday. And when we calculate it, so we've got 2 weeks already out, so therefore the 15th day is a Monday. So therefore the century ends on a Monday. And finally, for the 4th century, it starts on a Tuesday. However, this time, the 400th year does not have any extra days. So technically, we have 5 times 4 and a 1, since that one is actually a leap year. So therefore, we get a total of 21 days, which can be distributed across 3 weeks. So the 4th century, ends on a Sunday because that's the end of the week. So therefore, the starting days are Monday, Saturday, Thursday, and Tuesday. And the days that centuries end are Friday, Wednesday, Monday, and Sunday. So as you can see, Monday is the only day which is feasible for any century to begin or to end. So Monday, option 1, is the day of the week which can be the first as well as the last day of any century. So Monday is the right answer. Tuesdays, they are present at the start, but they're not present at the end. Fridays are present at the end, not at the start. Wednesdays are present at the end as well. So, the right answer is option 1, Mondays. Now that concludes this episode of TALLENTEX. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Brain Blitz Audios. If you want to get the latest updates from our channel, then please don't forget to hit the bell icon present below the video. So until the next episode, take care, stay safe, bye-bye for now.